Good morning. I guess good afternoon if you're doing this later on. But we are going to move on with our next section in our stats unit 10.4. But before we do, let's make sure we're okay with some of the things we discussed in 10.3. So I want you to warm up your brains a little bit and identify the method of data collection the situation describes. Look back at your notes and look back through all of the different methods that we discussed. And so the first one says that a researcher places 20 plants in natural sunlight and 20 plants in artificial light. The researcher then compares the growth of the plants after 10 weeks and determines which light is better. Second one says a researcher records whether people at a gym clean the machines after they use them. Drop your answer in the Ed Puzzle now. Hopefully, let's see what you got. For the first one is an experiment, right? If we are looking at two different plants, I guess the same plants, but comparing natural sunlight to a treatment, the artificial light, and comparing those results, because of that treatment, it causes that to be an experiment. The second one is observational, right? So if a researcher is just recording whether the people at the gym clean or not, there's no treatment being done. There's no, anything different. So it is strictly observational. Okay, great job. All right, so for the next few days, this section 10.4, we're going to be focusing on how can you use an experiment to test a conjecture, right? A conjecture is just like your idea. And so how can you do that successfully? There is a ton of vocab. And I'm sorry about this. This unit is definitely different, right? There's less number crunching and more of ideas and words and reading and vocab. So I'm going to read through these, but I also want you to pause your video and copy all of them down. I know it's a lot, but it'll be helpful in the end. Controlled experiment, an experiment in which two groups are studied under identical conditions with the exception of one variable. Controlled is your hint there, right? We are controlling most of the conditions except for one. Control group is the group under ordinary conditions that is subjected to no treatment during an experiment. Control just means that, okay, I have control of this. I'm not going to treat this. I'm going to treat the other group, and this is what I'm going to compare it to. So that's our control group. Treatment group then is the group that is subjected to the treatment in an experiment. Randomization, a process of randomly assigning subjects to different treatment groups. It's kind of in the name, right? So let's add on to that. Randomized comparative experiment is an experiment in which subjects are randomly assigned to the control group or the treatment group. So we are randomly assigning people to either group. That way we can conduct our experiment. Placebo, you may have heard of the placebo effect, right? It is a harmless, unmedicated treatment that resembles the actual treatment, but is not the treatment at all, right? Replication, the repetition of an experiment under the same or similar conditions to improve the validity of the experiment. So let's say we design an experiment and we realize that, okay, it's not going to produce the most valid results. I am going to replicate it. So I'm repeating the experiment, but I'm going to improve the validity, change a few things so that I can get better results. I know this is a ton, but if you haven't already, finish writing out those definitions. All right, so let's dive in a little bit deeper with some of those words. We want to determine whether each of these studies is a randomized comparative experiment. If it is, we'll describe the parts, meaning the treatment group, and the control group. If not, we'll explain why not. Okay, here's the first study. The first study says that at a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol levels than patients in the other group. Okay. So our first task was to determine Is this a randomized comparative experiment? Well, it is in fact, oops, not, that's what I meant to do, is not because the individuals were not randomly assigned to a control group and treatment group. Remember that that's one of our requirements for that. If you look back at our definition, is that an experiment in which subjects are randomly assigned. Well, in this study, they were given the choice. They were not randomly assigned. So right away, I know that it's not a randomized comparative experiment, okay? Therefore, since it's not, the conclusion, we don't know if it is valid or not. This conclusion that, oh, okay, 15% lower cholesterol levels, so I can't correlate those two, right? There may be other reasons why those patients who took the supplement have lower cholesterol. We can't make that correlation. Okay, let's look at the second one. Oops. To test out the new design of its self-checkout, a grocer, maybe like King Soopers or something, gathered 142 customers and randomly divided them into two groups. One group used the new self-checkout and one group used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. Okay, so remember our goal. We first want to determine, is this a randomized comparative experiment? Yes, it is. Okay. They were randomly assigned into two groups. Cool. Into that treatment and control group. So now what are those groups? Since it is, well, the treatment is the use of the new self-checkout. Our two groups are the individuals who use the new self-checkout. So that's the treatment group, the group that's testing out the treatment. And then the control group, the individuals who used the old self-checkout. This is an example of, okay, my data at the end, that is valid. My conclusion is valid because I had a valid experiment. Okay, so give a shot at it. I want you now to read the study and determine first, is it a randomized comparative experiment? If it is, describe the parts, the treatment group, and control group. If it's not, explain why not. Okay. Drop your note in the Edpuzzle as well. Ready, go. All right, let's see how you did. So this study says that a recent study shows that adults who rise before 6:30 a.m. are better drivers than other adults. The study monitored the driving records of 140 volunteers who always wake up before 6:30 and 140 volunteers who never wake up before 6:30. The early risers had 12% fewer accidents. Hopefully you said, no, this is not included in that category because individuals were not randomly assigned to a control group and a treatment group, right? It's just what they do. They weren't assigned to that. So the conclusion may or may not be valid. There may be other reasons why early risers are better drivers. Okay. All right. If you have a question on that, drop that in the Edpuzzle. Okay, moving on. So we've been talking about experiment, but we also have these observational studies. That was another one of your methods of collecting data, right? And there's two key things that I want us to get out of these experiments and the observational studies. And that is correlation and causality, right? So basically, and I'm going to jump down here because it's a little bit more important, that an observational study can identify correlation between variables, but not causality, okay? What that means is your pattern may be similar. Like we saw in some of these previous examples where we're like, well, if one thing increases, maybe the other thing increases. And you're like, okay, one thing causes the other. Correlation and causation, very different. Correlation just means they have the same pattern. Maybe it's coincidence, right? Maybe it's another factor, another variable that is coming into play to make it have that same pattern. Causality or causation actually means that one thing causes the other. Keep in mind, in an observational study, we can identify correlation. We cannot determine causality. Okay. All right. Now, if you look back though at the experiments that we just were discussing, If we have a true randomized comparative experiment, then we can make valid causation conclusions, meaning cause and effect, right? So just to note the big difference on those. If I were you, I'd write a note about that, maybe not as specific as this, but just know that in an experiment, we can have causation. In observational study, we can have correlation, but not causation. Okay, let's dive into that a little bit deeper. Explain whether the following research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or observational study. Okay. Here's our goal. You want to know whether vigorous exercise in older people results in longer life. So our first goal, should we investigate this through an experiment or an observational study? Well, ethics says that we should probably do observational. It's not ethical to assign to older people vigorous exercise, right? That's probably against good ethics. So what would be a good design is to randomly choose one group who already exercises vigorously, and then randomly choose one group of participants who do not exercise vigorously. Then you're going to monitor the ages in both groups at regular intervals. And then we should be able to identify a correlation between vigorous exercise in older people and longevity, but we won't be able to say one causes the other. Okay? We may be able to conclude that vigorous people who, how would I say this? We cannot say that people who exercise vigorously live longer. We can't say that one causes the other. Okay. All right. So now you give it a shot. You're going to do the same thing that we just did. So you're going to determine if this, and I'll read it. You're going to determine first, is it best used as an experiment or an observational study? And then go into that a little bit more. What would that look like? So here's our goal. We want to know whether flowers sprayed twice per day with a mist of water stay fresh longer than flowers that are not sprayed. So first, should this be an experiment or an observational study? Drop it in that puzzle. Okay, hopefully y'all said an experiment. Now, I want you to think of, design that experiment a little bit, elaborate. Drop that in that puzzle. One idea may be to randomly select the same number of flowers to be put in each of the two groups, spray flowers in one of the groups twice a day with that mist of water, and don't spray the other group. Keep everything else constant, temperature, right, amount of sunlight, things like that, and record how many days flowers in each of those groups stay fresh. Then you've actually created a great randomized comparative experiment that you can conclude causality. Nice job. One last little bit to discuss, how to analyze experimental designs, okay? Let's say that a pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. First, we want to kind of read through this experimental design. And we're going to go through a few different ones, but this is our goal, right? But we want to identify potential problems in each of them and then describe how we can improve it. So again, the goal, what's going on, the company wants to test the effectiveness of a new chewing gum designed to lose weight. They designed this experiment that says, okay, we're going to identify 10 people who are overweight. 5 subjects are given the new chewing gum and the other 5 are given a placebo. After 3 months, each subject is evaluated and it is determined that the 5 subjects who have been using the new chewing gum have lost weight. Okay, a few things going on here. Remember that placebo is just the unmedicated treatment. So maybe they're given gum that actually doesn't have any of the treatment in it, right? So we want to see, is there a potential problem with this? Well, there is. The sample size is not big enough. If we are looking at 5 people, essentially compared to 5 people is not enough to make a valid conclusion. We want more. Well, that leads into how we can improve this. Just increase the sample size, replicate that experiment, That goes back to one of your vocab words, right? Replication. Just means to repeat the experiment exactly how it was, just with more people, because everything else looks good. We are randomly selecting of the overweight population and then comparing the two. Okay. All right. Let's look at another example. What about now the company identifies 10,000 people who are overweight, so they increased. The subjects are divided into groups according to gender. Females receive the new chewing gum and males receive the placebo. After 3 months, a significantly large number of female subjects have lost weight. What's the problem here? The problem here is that our groups are not similar. If we gave all of the females and all of the males their certain type, right? So we gave all of the females the chewing gum and all of the males the placebo. We can't compare that. We can't make a conclusion because the groups are not similar. We would have to randomize within. So a potential improvement to make would be divide subjects by gender. So first, divide it into males and females, kind of what they did, but they did it intentionally with the treatment. So let's divide by gender, and then within each group, randomly assign who gets the placebo and the treatment to better our results. Okay. All right, I've got one more for you. We keep changing the same experiment, right, with our goal. Oops. Now you can already see that, but so our last variation of the experiment is to identify the 10,000 people who are overweight. We've got a good sample size. The subjects are divided into groups according to age. Within each age group, subjects are randomly assigned to receive the new chewing gum or the placebo. And then after 3 months, a significantly large number of the subjects who received the new chewing gum have lost weight. Well, guess what? There's no potential problem here. We grouped by similar characteristics. We randomly assigned within the groups. We had 2 groups. We had our control group and our treatment group. So absolutely, we are able to then conclude causality and say, well, okay, if a significantly large number of subjects received that chewing gum and lost weight, we can then conclude causality that says that it was because of the gum. Pretty cool. Okay. If you have questions on that, drop it in the Ed puzzle. But guess what? That's it, right? So I know this unit's pretty weird because it's just a lot of vocab and words and designing experiments and talking about different studies. But you're doing great. We just have one more video lesson and then I'll be back. So start working on your 10.4 in Big Ideas. It'll be due Wednesday night at midnight and you will have all class period tomorrow. You should be watching this on a Monday. So you should have all class period tomorrow to work on the Big Ideas assignment. This one's pretty short. So if you want to wait and do it tomorrow during class, I think that's probably a good idea. But it ultimately is due Wednesday night at midnight. Okay, great job, and I'll see you next video.